Lesson number 3. All right, what did we talk about yesterday, class, and the day before? What have we gone over so far?
I believe we talked about yesterday about graduated cylinders and pipette.
Right, wonderful. And then, Edith, what about Monday?
Beakers and I think it was flasks.
Right, beakers and flasks, wonderful. We talked about beakers and flasks, and graduated cylinders and pipettes. And these are the basic tools a person who is mixing chemicals will use to do so. So today, we're going to use all the skills that we've learned so far to mix a very specific solution. All right, on your desk, you have salt. You have beakers. Actually, I'm just going to write lab equipment, because you have beakers and flasks and graduated cylinders and pipettes. Lab equipment. You have salt, lab equipment, water, agua, water, H2O, dihydrogen oxide. There we go, that's the other chemical name for it. You also have food coloring. Now, what was the extra credit from yesterday? You guys did so great on it.
Food coloring. Yeah, was it?
The food coloring, yeah, was it?
We had to make it light blue.
Right, you had to make it light blue.
It was surprisingly difficult.
It was surprisingly difficult, exactly. So today, we are going to be mixing a solution. I want you guys to make a light blue saltwater solution. Your solution should have close to 10 milliliters of salt. Usually we don't measure solids in this way. Usually we use something called a triple beam balance. But in the kind of like, we only have so much time to work on things, and the I'm okay with a little margin of error here, we're going to use our liquid beakers and flasks and graduated cylinders to measure 10 milliliters of salt. All right? It's a very specific amount of salt, but kind of close to it. All right? If I tap it a couple times and it's just a little bit below 10 milliliters, I'm cool. I'm fine with it. But if it's lower than like 5, I mean like, maybe try again. All right? We need 10 milliliters of salt. I would like for you to put in 155 milliliters of water. Exactly that much.
Okay.
You guys have the tools,
Mm-hmm.
beakers and flasks, graduated cylinders and pipettes, to get 155 milliliters of liquid. All right? And then I would also like you guys to make it with 0.5 milliliters of food coloring.
Wow.
Yes. I know, it's quite a bit. Altogether, how much liquid, how much stuff are you mixing together? How many milliliters?
I'm gonna say 165 and 500.
500ths. All right, let's do a little bit of place counting. All right, we've got our ones, right?
Mm-hmm.
We got our tens, then we got our hundreds, right? What about the other way? Where do we start going over here?
Hundreds? Or did we start at tenths?
We start at tenths.
Oh.
Yes, we go from 1 back. So this is the starting place. We can't really start between 1 and 0.1, right?
That's true.
Right? Or we can't start between 1 and 10, right?
Yeah.
Otherwise we'd call it like fifths and sixths, and that would be silly for us.
That's
So we
true.
start at 1, and we can go 10, or we can go tenths.
Tenths, so
So 10 left, 10th right.
165 and 5 tenths of
Stuff.
Right. Thank you.
Ruh-roh.
Ruh-roh.
Alright, so we've got that many, and then this many, and that, and then this, and then this. 155.5 milliliters of stuff all together. And all of these things together will come out to make 1. Now I have chosen these numbers very carefully
Mm-hmm.
because we're going to use our solutions tomorrow.
Oh.
Oh, yes. So it's very important that you get this many of this, this many of this, and this many of this. Or close to this many of this, but these two have to be pretty accurate. Alright, what you'll end up with is a blue saltwater solution. Alright, you guys ready?
Yes.
Yeah.
Alright, this is gonna be pretty much free, you guys doing whatever you wanna do to get to this point, right? You have a lot of ways to do it, I promise.
Okay.
What's it flask for?
Stirring. No,
Stirring,
Yeah.
swirling,
Swirling.
mixing.
Mixing.
Right, it's used for all of those things, those are all synonym words. Alright, flasks are where we mix our solutions. Beakers, what's a beaker for?
Measuring liquids and sometimes salt.
Measuring liquids and sometimes salt, you're right. Beakers are mostly used to store large quantities of liquid.
Oh.
Yes, our really good measuring tool is the graduated cylinder and pipette.
Oh, that's right. Because
Right.
it's more accurate.
Yes, Edith.
What do I measure the salt with?
What do you measure the salt with? You should measure the salt using a small beaker.
Okay.
Yes, or a graduated cylinder before you've started measuring your liquid with your graduated cylinder.
Okay.
All right, if you measure your salt after your water, it's gonna get stuck to the sides of your graduating cylinder, and that's gonna confound. I'm gonna write that on the board because I like that word. Confound. Can you guys say confound?
Confound.
Can you guys say angry when you say it?
Confound. Confound.
Right. So that will confound your variable. It will become what is called a confounding variable. A confounding variable means something went wrong.
Oh.
Yes, confounding variable. Confound it. It's like if you're watching a cartoon, it's like, confound it all! It's like saying, everything was messed up!
I see.
So, a confounding variable means something got messed up. So if you do your salt before your water, probably not gonna happen. If you do your water, if you do your salt after your water, it's gonna get stuck to the sides. And then it'll be less salt than you want. Alright?
Alright.
Wow, exactly. Mind blown. All right, so ready, set, science.
Okay. Just drop it here, drop it